Hello, Algebra 2 Trig students. This is Mrs. Leopold, and I'm going to explain the main concepts of Unit 2, Lesson 1, which is about quadratics. And this time we're going to talk about quadratics in general form. That's our main idea, and you're going to look at the quadratics in general form, and you're going to ask yourself at the end, can I graph an equation if I see a quadratic in general form? And to graph the equation, could I find its vertex? Do I know what an axis of symmetry is? Do I know how to factor? Do I know how to find the zeros of the graph or the places where the graph crosses the x-axis? So that's your goal for today. We're going to go through this and then we'll talk about each one throughout the lesson. You can always pause, rewind. You can always go see your teacher if you're not understanding something, because I'm going to skip over some stuff but go through the main ideas of this lesson. So general form is y equals ax squared plus bx plus c. In the past, you might have heard that as standard form. We're just going to start calling that general form now. So your a is the number in front of the x squared, the coefficient in front of the x squared. The b is the coefficient in front of your x, and your c is just the number by itself. Now, what is significant about the letter or the number c? So you might want to write this. That's going to be your y-intercept, right? So what is a y-intercept? A y-intercept is the place where the graph crosses the y-axis. So if I put in 0 for x, right, I put in 0, these two terms are going to disappear, so I'm only going to be left with c, so therefore c is my y-intercept. Now, the axis of symmetry, right, if you were to draw or graph a parabola in general form, we would graph it, let's say, somewhere here. So my axis of symmetry is the axis that goes through the vertex and splits the parabola into two equal parts. So if I folded the graph on the green dotted line, then I would have the left-hand side of the parabola match up completely with the right-hand side of the parabola. And all these points, because it's symmetric, so all these points would match with each other. So the green dotted line is the axis of symmetry. Now the axis of symmetry needs to be written as an equation because it is indeed a line. This vertical line is the axis of symmetry, so it needs to be an x equals. Now how do I get the value of that? Well, we have a little formula here, and it is negative b divided by 2a. So you take the value here, the opposite of whatever this value is, negative b, and you divide it by 2 times the value coefficient of a. Of course, if the axis of symmetry is negative b over 2a, then that would be the x-intercept of your vertex. So that is how we could find the x-intercept of our vertex. Again, the x-intercept of the vertex is the same value as the axis of symmetry. How do I find the y value for the vertex? Well, hopefully you're saying to yourself, oh, that's easy, Mrs. Leopold. I just plug in this x coordinate into the equation. So whatever I get for the x value, right, I'm just going to plug that into x, and then recalculate to get my y value. So it's f of negative b over 2a, meaning just plug this value into the equation, and then you will find the corresponding y value. Okay, so let's practice on the one right below. So I'm going to use these strategies. So I'm going to first identify that what is my letter A? My letter A is 1. What is my letter B? My letter B is negative 2. What is my letter C? My letter C is negative 8. So first I want to potentially find the axis of symmetry, right? So the axis of symmetry we find by taking negative b over 2a. So my axis of symmetry is a negative 2, because b is negative 2, so it's negative 2 divided by 2 times a, which is just 1. So when I simplify this, a negative 2 is positive 2 divided by positive 2 is 1, so my axis of symmetry is at x equal to 1. So I'm going to graph that x equals 1. This is my axis of symmetry. Now that's helpful because my axis of symmetry, the x-coordinate, so if I'm trying to find the vertex, the x-coordinate of the vertex is the x value of the axis of symmetry. It's the value of the axis of symmetry. Great, now how do I find the y-coordinate of the vertex? Well, I have this equation, y equals x squared minus 2x minus 8, right? That's my equation right there. I'm trying to find when x equals 1. So I'm going to substitute in 1 for x. So y would equal what when x is 1? So y equals 1 squared minus 2 times 1 minus 8. So if I were to calculate that in my head, I'm going to get 1 squared, which is 1, minus 2 times 1, which is minus 2. So 1 minus 2 minus 8 is negative 9. So I go ahead and graph that point. So I'm going to go to the right one, down negative 9, which is right here in my graph. And this is the vertex of the parabola. Now the rest you should know from the 1 to 1, 2 to 4 relationship. Remember I did the 1 to 1, 2 to 4. It's 1 and then we square 1 and then we 2 to the right and left and then we square 2. So from there I'm going to go right 1 up 1, left 1 up 1, right 2 up 1, 2, 3, 4, left 2 up 1, 2, 3, 4, and here would be the graph of my parabola. That's it. All right, so here we are with example 2. You can pause. I would encourage you to pause and try this 100% on your own. Look at the example we just did above. And then check it with me. So go ahead and try that on your own. So you should have gotten an axis of symmetry of x equals negative 1, which means the x-coordinate of my vertex is negative 1. I'm going to try to find the y-coordinate of the vertex. How am I going to do that? I'm going to plug in negative 1 into my actual equation. So I have negative 3 x squared, well x is negative 1, minus 6 times x is negative 1. So I'm actually going to calculate this. So I would get negative 3 times 1 plus 6 plus 5. Double negative here gives me positive 6. So when I add that all together, 11 minus 3 is 8. So my y-coordinate of my vertex is positive 8. So I go left 1, up 8, and this is the vertex of my parabola. Now, one of the things I didn't highlight in the last example, which I would like to do here, is this is our y-intercept. I talked about it, and I didn't use it graphically, which is the most important part. So remember, if I plug in 0, I get my y-intercept of 5. It's not the most important part, but it is something that's really handy when you're graphing. So I can graph my y-intercept, which immediately, you know, a parabola is symmetric. So if it goes to the right one down 3, then I'm going to go to the left one down 3, and there's automatically a third point on my parabola. We are going to ask you to graph 5 points on a parabola. So that's just the start. Really the number I want you to look at, remember that 1 to 1, 2 to 4 relationship I talked about? And when you have this negative 3 as a leading coefficient, remember you take the y value and you multiply it by negative 3. So that's why we went right 1 down 3 and left 1 down 3, because usually we go down 1, right? But at this time we're going to go down 1 times negative 3, which is negative 3. Usually we go right and left 2 down 4, but I'm going to go right 2 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so I'm going to go triple that amount and then symmetric. I'm going to go over here and do the same thing. And then I'm going to do my best to connect those points smooth as a curve. And there is my parabola. Awesome. All right, and there was a huge section in your notes that was about factoring, and I skipped it, so you should read through that. If you're struggling with factoring, you should read through how to group. I'm just going to move on and go right to factoring. So if you need a little moment to review factoring, please look up on Khan Academy how to factor. Look at that example, but I'm just going to jump in here. So why would we factor? When would we need to do this? Well, if we're trying to find the x-intercepts, right? If we're trying to find the x-intercepts, that's when the y value is 0. So that means we're going to set y equal to 0, and then we need to solve for x. So the x-intercepts, remember, are where the graph crosses the x-axis. So if you need to remind yourself of that, so where the graph crosses the x-axis, those are the x-intercepts. How do I find the x-intercepts? I plug in 0 for y. So when you're solving a quadratic equation, you're technically finding the place where the parabola is going to cross the x-axis. So how do I factor this? Well, I like to jump right into my factors, right? What two numbers multiply to give you -10, but add to give you -3. So hopefully you're saying -5 plus 2. -5 times 2 is -10. -5 plus 2 is -3. So my two factors are x minus 5 times x plus 2. And then I have to use my zero product property, which means either this parentheses has to equal 0 or this parentheses has to equal 0. And so my two solutions are 5 and -2. So this literally means I would have my parabola, it would cross at 5 and -2. I have a +1 coefficient, which means it's going to open upward and go through those two places on the x-axis. I don't know the vertex, but I could find it by using the -b/2a if I wanted to. Okay, letter B. So letter B, I'm going to let y equal 0 because I'm trying to find the x-intercepts. Now this time, again, I like to jump right into my parentheses. What two things multiply to give me 2x squared? My only options are 2x and x. What two numbers multiply to give me -3? My only options are -3 and +3. So if I experiment here, or I'm just visualizing, my inside and outside terms need to add up to +5x. So this is -3x, this is +2x. Okay, that didn't work. So how about if I reverse it? So if I put 3 here and 1 here, and then try the inside, this would be -x. Let me erase that so it's not confusing, sorry. So I would try the inside, which is -x, the outside, which is +6x, and -x plus 6x gives me my +5, and -1 times 3 gives me my -3. So that did it. I have my two factors. Now you can do the thing that's shown in the notes, you multiply 2 times -3 to get -6. So it's what two numbers, or they're going to multiply to give you -6, but add to give you +5. So it's +6 minus 1. Then you do your factoring by grouping, 2x squared plus 6x minus x minus 3. So we put these two terms into here. The first term is 2x squared, last term. Then we factor by grouping, right? And then we would get 2x minus 1 times x plus 3. This should be faster. You should be at a stage where you can start kind of visualizing this and figuring it out, but it's really up to you. If you need help with factoring, please come see me. But again, when you solve, what are you solving for? You're solving for the two places where the graph is going to cross the x-axis. So the graph would cross the x-axis at -3, it would cross it at 1/2. It's a +2 coefficient, which means it's going to be opening upward and going through those. I don't know where the axis of symmetry or the vertex is, but I could find it if I wanted to. Okay, if you don't like factoring, I would still encourage you you're going to have to factor, in pre-calculus and calculus and all your classes after this, so you should practice your factoring. But if you don't want to factor and you're really good at the basic math, add, subtract, multiply, divide, then you might want to use quadratic formula. I personally think that takes a little longer, and I think you might make mistakes, but sometimes you can't factor, and so you need to use the quadratic formula. So the quadratic formula, remember our a is the coefficient in front of the x squared, b is the coefficient in front of x, c is our number, just our y-intercept, or just the number with no variable attached to it, it's our constant. And so you can identify your a, b, and c, plug into this formula here, and you would find the two roots of the equation. So it's the roots equal negative b plus or minus the square root of b squared minus 4ac, and that entire numerator is on top and then divided by 2a. So even though letter A is factorable, we're going to go ahead and practice using the quadratic formula because all of them won't be factorable. So let's go ahead and practice. So A equals the coefficient in front of x squared, which is 1. B equals the coefficient in front of x, which is negative 8. And C equals the constant, which is 16. So x equals, it's negative b, right? And b is negative 8. Oops, sorry about that. In highlighter mode. B is negative 8. And then it's plus or minus the square root of b squared minus 4 times a times c. Notice I'm parenthesizing all the time. I like to parenthesize because I want to make sure my negatives are getting treated properly. So b is negative 8, a is 1, c is 16. So I'm plugging in those numbers, and I'm parenthesizing just to create that good habit. In case the number is negative, then I'm making sure I square the negative, or I recognize a double negative right here. So some of you are going to do the math in your brain, and you're going to put the proper positives or negatives. That's fine. But you might want to write it out very carefully until you get used to it. So what do we get? We get negative 8, which is positive 8. Underneath, I'm going to have 64 minus 8 squared is 64. 4 times 16 is actually 64 as well, and that's all divided by 2. So that's 8 plus or minus square root of 0 divided by 2. Well, the square root of 0 is just 0. So 8 plus or minus 0 is just 8, and 8 divided by 2 is 4. So what does that mean? It means we only have one root. Well, you can see here this parabola only has one. So this is one real double root. And when you have a double root, it bounces off of the axis at that x value. So it comes down and it bounces away, or it comes up and it bounces away. It's coming down because it has a positive leading coefficient of 1 here. If it had a negative leading coefficient, we would be opening downward. Now, if this number comes out to be a whole number right here, that means we could have factored it from the very beginning, right? So if we look at f of x equals x squared minus 8x plus 16, when we set this equal to 0 to find the x-intercepts, you could have said, what two numbers multiply to give me 16, but add to give me negative 8? Well, that's negative 4 times negative 4. So it's the same root. 4 is a double root. A double root means that's where the vertex is located right on the actual x-axis. Okay, B and C do not factor, so I want you to go ahead and try these on your own. So use the quadratic formula and look at it right above and see if your answers match up with the x coordinates. So these graphs that I have beside the examples, they're on the next page, so you can kind of check it out. It's on the right-hand side. I just put them in the actual solving itself because I think it's helpful. So go ahead and practice. Use your quadratic formula, pause, try it on your own, and then see if we have the same answer. Or you can follow along, but I would encourage you to pause and try it on your own. Okay, so did you get -1 plus or minus the square root of 96 all over 6? Okay, why did I take that negative away? Well, if you divide a positive or negative by negative, you're just going to get a positive or negative, so it really isn't significant anymore. So what are these numbers? Well, clearly they're just going to be decimal answers. So you're going to have -1 plus the square root of 96 divided by 6. So you could plug that into your calculator, or you could put -1 minus square root of 96 divided by 6. Plug that into your calculator. So we get roughly, I don't know, if you want to do square root of 96 is 100, is close to 100, square root of 100 is 10. It's -1 plus 10/6, which is 5/3, so that's going to be roughly 2/3, so I have that over here. And then -1 minus 10/6, that's -1 minus 5/3, so that's -8/3, so that's going to be roughly over here. Okay, so that's what we have. Now, what we're looking at, I didn't highlight on the last one, is we're really looking at what's underneath this radical. So there was a 0 underneath the radical for part A, and we had 1 real double root. When there's a positive number underneath the radical here, we have 2 real roots. They're different roots, they're crossing the x-axis at different places. Now, if you do letter C, again, I would pause, try it on your own. I'm going to pause this time. I'm not going to show you all the work. I'm just going to do it on my own and show you the answer when I'm done. Okay, so something unique happened on this example. You got a negative number underneath the radical, and you might be saying, wait a minute, I can't take the square root of a negative number. If you plug that into your calculator, it's going to tell you there's an error or it's not possible. So you can't take the square root of a negative right now. And so if you can't take the square root of a negative, that must mean there aren't any x-intercepts, right? So this wasn't possible to solve, which means the graph is not going to cross the x-axis. So the number underneath the radical was negative. Up in the one above, the number underneath the radical was a positive number, and we had 2 distinct real roots. There were 2 different real roots. And in the example before this, we had a 0 underneath the radical, and we had 1 real double root. And that brings us to something called the discriminant. So the discriminant is useful because it's going to tell you something about the roots of the equation without actually doing the quadratic formula. So if you have a negative number underneath the radical, so remember this is the part underneath the radical, because the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So we are specifically talking about the portion underneath the radical, right? If the portion underneath the radical is 0, that means we have 1 real double root. And graphically, what does that mean if you were to sketch the graph? That means the graph is going to come down and the vertex is right on the x-axis and it's going to bounce away, or it's going to come up because it's a negative leading coefficient, it's going to bounce away because it's a double root. If the b squared minus 4ac is greater than 0, then I have 2 distinct real roots. So that just means graphically that if you were going to look at this parabola, it's going to either open down with 2 different locations where it's going to hit the x-axis, or it could open up with 2 different locations where it goes through the x-axis. So 2 distinct real roots. If the value underneath the radical b squared minus 4ac, oh sorry, this is missing a c, apologies, is negative, right, if it's less than 0, then you have no real roots. And so graphically, what does that mean? It means your graph is floating above, the vertex is above the x-axis and it's opening upward, or the vertex is below the x-axis and it's opening downward. So it does not go through the x-axis. So look at example 5, pause, try it on your own, do the b squared minus 4ac, and see if you can determine, is it going to have 1 real double root, is it going to have 2 distinct real roots, or is it going to have 0 real roots, no real roots? Sorry, I made a mistake there. So A is 3, B is 2, C is 1. B squared minus 4AC is 4 minus 12, which is negative 8. If you have a negative underneath the radical, underneath the square root sign, so I'm saying radical, this is the radical sign right there, then that means we have no real roots. Graphically, that means your graph would not cross the x-axis. So you can see this is a positive leading coefficient. That means the vertex would be above the x-axis and it would be opening upward. Okay, our final example here is a real world example. So we're going to go ahead and go through this, hopefully put some things together. I tried to put it all on one page so we wouldn't have to look at it, but that means that I'm going to have a hard time trying to do some of these answers in the space, but I'll do my best. Okay, so it says a miniature rocket is launched off of a roof. The height of the rocket in meters with respect to time in seconds can be modeled by this function. So the height at any given time would be negative 10t squared plus 60t plus 15. So how high is the roof? Well, the miniature rocket is launched off the roof, which means at the very start it's on the roof. So if it's on the roof at the very start, how much time has passed? Hopefully you're saying to yourself, oh, no time. That's right. So 0 seconds have passed because it starts on the roof. So in other words, we're just trying to find the y-intercept. Where did it begin? So you're doing h of 0. So we have negative 10 times 0 squared plus 60 times 0 plus 15. Hopefully you didn't even need to write this out. You're like, oh, this is 0, this is 0. So where did it start? It started 15 meters above ground, or what it asked is how high is the roof? The roof is 15 meters from ground level. All right, the next one, how high is the rocket 1 second after launch? So what did they give us here? They gave us the time. Time is 1 second. So you're just going to plug in h of t, h of 1. So you can pause and try all of this on your own and then check with me. That would be better if whenever you pause and try to do this thinking on your own, that's good for your brain. So I get negative 10 plus 60 plus 15. So that would be 65 meters after 1 second. So down here, eventually I'm going to sketch a graph. So if I were to start to sketch some of these points, right, here's my x-axis. My x-axis is in seconds. Here's my y-axis. My y-axis is in meters. I know at the start, I am at 15. Oops, I'm going to go backwards. I'm going to put this at 15 here. This is 65. So at 15, it's here. After 1 second, it's at 65 meters. So we know it's going up like this. Question number, letter C, says, what is the maximum height? Where would the maximum height be in relation to a parabola? As we can see, that's going to open downward. So the maximum height, hopefully you're saying to yourself, oh, right, what do we call this point? This is the vertex. So I need to find the vertex, or not even the vertex, but the x-coordinate of the vertex, because it says, oh no, we don't, sorry, apologies. Not the x-coordinate, but the what? It's asking for the maximum height. The x-coordinate is time in seconds. The y-coordinate is the actual height, right? So the x-coordinate was time up here in seconds, and the y-coordinate was our height. And we can see that here as well. But I do need to find the x-coordinate of the vertex so I can plug it in to find the y-coordinate. So how do I find the x-coordinate of the vertex? Remember at the beginning of the lesson, it's negative b over 2a. So b is 60, a is negative 10. So I get negative 60 divided by negative 20, which is 3. So after 3 seconds, so I'm putting that on my graph, after 3 seconds, I can find its maximum height. So now I just plug in 3 for time. So I get negative 10 times 3 squared plus 60 times 3 plus 15. So go ahead and calculate that. So 3 squared is 9. 9 times negative 10 is negative 90. 6 times 3 is 18, so it's 180. 180 minus 90 is 90. 90 plus 10 is 105. So how high does it actually go? It actually goes up to 105 meters. Great. Now letter D, it says how much time will elapse before the rocket hits the ground. So I want to know, what is this time right here in my graph? So how much time will have elapsed before the rocket hits the ground? Well, that is when it hits the ground, that means I have a height of 0. So in other words, I'm trying to find the x-intercept, and the x-intercept is when I have a height of 0. So I'm going to do 0 equals negative 10t squared plus 60t plus 15. This is where I don't have enough room to do all the actual work, but this is not factorable. You could start your life, make it way easier. They're all divisible by 5, right? So I can divide 0 by 5, negative 10 by 5, 60 by 5. So I would get that as negative 2t squared plus 16t plus 3. That way, when I use the quadratic formula, my numbers are much better. Sorry, excuse me, that's not supposed to be 16. Apologies, that is supposed to be 12. Whoopsie. So that's negative 2t squared plus 12t plus 3, that equals 0. Take your A, your B, your C, do the quadratic formula, and see what you get. You can get a decimal answer. Yeah, go ahead and get a decimal answer so you can actually graph it. Otherwise, you're not going to know. So I'm going to pause and let you do that on your own. Okay, so you can see down here, I did my quadratic formula. Sorry, I really ran out of room. I had negative 12 plus or minus the square root of 144 minus 4 times negative 2 times 3 divided by 2 times negative 2. So I get 12 plus or minus the square root of 168 over 4. When I separated that into 12 plus square root of 168 divided by 4, I got 6.240 seconds. When I did 12 minus the square root of 168 divided by 4, I got a negative value. And you can see there's going to be a negative value because it's going to be over here. So you should already know that from your graph, right? But what it did was it told us that this is going to be 6.240. So why are we asking for a practical domain? Well, does it make sense to have negative values over here, negative time? No, your time is going to start at 0, and I'm going to include 0 because that's the height of at 0 seconds, you have to start right at the beginning, which is 0 seconds, and then the rocket gets launched. And then it ends when the rocket hits the ground. Does it go into the ground? Well, if it's a giant, I guess, rocket, but we're assuming no, it doesn't go into the ground. So it ends at 6.240 seconds, again inclusive because it has to hit the ground in order to end. If you wanted to put here instead 3 plus the square root of 168 over 4, or 12 plus the square root of 168 all over 4, that's fine. But you can also leave the 3 decimal second answer as well. It's just whether or not it's calculator. If this was a non-calc problem, you wouldn't be able to do that, so you'd be leaving your answer as just the 3 or 12 plus or minus square root of 168 over 4, or 3 plus or minus, plus only, plus because the negative didn't work because it was a negative time. All right, that's it. Again, lots of information here. Make sure you practice, make sure you ask questions, and I will see you soon. Bye.